Okay, this is Algebra 2 4-7b, which is on page 137. It's the problems, okay? And what we're doing here, I believe what you're gonna find is that the same strategy of factoring to find a solution is what you're going to do. So we need to read our problem, we need to produce our equation, and then we need to find our solutions. Now, one extra step that we have to think about here is the possibility that one of the possible solutions will not make sense. That's possible. Okay, one of the solutions may not make sense. And we'll see if we come across anything like that. So we want to think about the solution set that we come up with. For example, if the problem is dealing with, say, distance measurements, right? And we factor and we find that a possible solution is a negative number, that's not going to make sense for the problem because we don't have a negative distance, right? You don't pull out a ruler and measure something to be negative 4 inches long. Okay? All right. So let's just dive into some problems here. Number 2 says find 4 consecutive integers, right? So remember that our strategy for consecutive integers is that there's the first one, and since they're consecutive, each consecutive one is one bigger than the last one, right? So if I start with, as an example, 2 as the first integer, the next integer would be 2 plus 1, or 3. The next consecutive would be 2 plus 2, or 4. And then the next consecutive would be 2 plus 3, 5. Okay? So always keep that in mind when you read problems about consecutive integers. Okay, so it says find 4 consecutive integers such that 3 added to the sum of the squares of the first and second equals the square of the fourth. Okay, so let's back up. 3 is being added to the sum, right? So what that says to me is that 3 is being added to some quantity that's going to be inside parentheses. And it's a sum of the squares of the first and the second. Well, what's the square of the first? That's n squared plus the square of the second. Now let's be careful there. That's n plus 1 squared. Okay? So 3 is being added to this sum right here. And that equals the square of the fourth. Well, the fourth is n plus 3. So that's n plus 3 squared. Okay, so before we can factor, we need to expand. Okay? In other words, I want to write this here as 3 plus n squared plus, now n plus 1 squared is n plus 1 times n plus 1. Right, so n times n is n squared. Insides, 1 times n is 1n. N times 1 is 1n, so it's going to be plus 2n. And then 1 times 1 is 1, plus 1. This tablet, I've really got to get it straightened out. All right, plus 1. Okay, now what does that equal? It equals n plus 3 squared, which is n plus 3 times n plus 3. Right, so n times n is n squared. We'll have a 3n there and a 3n there, which is 6n. And then 3 times 3 is 9. All right, so let's try to put this all together, right? If I subtract n squared from each side, Because remember, we're trying to set this whole thing equal to 0. Those will go away, and those will go away. If I subtract 6n from each side, I have 2n, I owe 6n, that's a negative 4n. Negative 4n. Those will go away. If I subtract 9 from each side, okay, so I have 3, I owe 9. This means I owe 6, but I have one more right there. So if I owe 6 and I have one more, I owe 5. You see how I did that? And then there's this n squared right here. So we end up with n squared minus 4n minus 5 equals 0 because I took everything off of this side. All right, so now we can take that trinomial and factor it into binomials, right? And what would that look like? Well, we're going to have an n and an n. That sign right there on the constant term tells me that these binomials are going to have opposite signs. That sign right there, because they're opposite signs, means the bigger number has to be with the negative sign. The only way you can multiply two numbers and get 5, or at least two integers and get 5, is a 5 times a 1. So I'll put the 5 with the negative and a 1 with the positive. All right, so now I have n plus 1 times n minus 5 equals 0. So we can separate these. Right? If n plus 1 equals 0, then clearly n must equal negative 1, which would suggest that the first integer is negative 1. Well, that's one possibility. Negative 1, 0, 1, 2. Right? So there's 4 consecutive integers. Right? Now, in the second case, n equals 5, and so this would be 5, 6, 7, 8. Now, it says just find 4 consecutive integers, and so I think either one of these is a possible solution, because integers can be negative, and 0 is an integer, right? So there we go. Okay. So that was number 2. Right? So again, what was the strategy? Read the problem carefully, produce an equation, and then work that equation so we could factor and solve. Let's look at number 4. The width and height of a room with a square floor total 24 feet. The width and height of a room with a square floor total 24 feet. If the floor and ceiling areas together equal the total area of the 4 walls, find the dimensions of the room. Oh my. Okay, let's see if we can figure this one out. I should probably do these before I just dive in and do them on. Anyway, so the first sentence, the width and height of a room with a square floor total 24 feet. So that sounds like I'm supposed to believe that the width plus the height equals 24. Right? Which we know that it's a square floor, and that's important to us because if it's a square floor, the width of each wall is exactly the same. Does that make sense? Right? Because that's the square, all the sides are equal, right? It says if the floor and ceiling areas together Now, presumably the walls go straight up, and so the ceiling would be a square the same area as the floor. So if the floor and ceiling areas together equal the total area of the four walls. Wow. All right, so how do we find area? Length times width, or in this case, because it's a square, it would be the width squared, right? Width squared of the floor plus the width squared of the ceiling, which would suggest that 2 times the width squared equals the area, total area of the four walls. And the walls, we're going to say, are width plus height, right? So there's one wall plus, sorry. Let's back up here. The area of a wall will be the width times the height. And we've got 4 walls, right? All right, so let's think about what I said here. Because the floor is square, it's W times W equals the area of the floor, or W squared. The ceiling is the same shape as the floor. It's squared, so it's W squared is its area. Or 2W squared is the total area of the floor and the ceiling. Okay? The width times the height is the area of a wall, and there's 4 walls. So we could also say that 2W squared equals 4WH, or 2W squared minus 4WH equals 0. Right? Now that makes sense. If my 2W squared is the total area of the floor and the ceiling, and my 4WH is the total area of the 4 walls, and they're equal, if I subtract one from the other, it's going to be 0. So let's factor. I can factor out a 2W, and I get a W minus 2H equals 0. Does that make sense? So that means that either 2W equals 0 or W minus 2H equals 0. Wow, what are we going to do here? Now over here, W equals 0, but that doesn't make sense, does it? Right? That doesn't make sense. Because you wouldn't have a 0 width, right? You're going to have a wall that's 0 feet. So this is out. So that means that W equals 2H. The width is twice the height of the wall. Okay? That's what that says right there. The width is twice the height of the wall. Now you might think, well, we're stuck here. But remember, W plus H equals 24, or 2H plus H equals 24, which means 3H equals 24, which means the height of the wall is 8 feet. And the width is twice the height, so the width is 16 feet. And we could substitute all this in and see if it worked. See if we got it right. Let's go ahead and do that. Let's suppose that we put, we'll do this right here. 2 times 16 squared equals 512. 4 times 16 times 8 equals 512. Yay! We figured it out. So that's a pretty cool problem right there. It gave us this equation. Then, from what we read, we derived this equation right here, which we set equal to 0, which we then factored. We found that one factor gave us a non-solution because you don't have a 0-foot wall. It just doesn't happen, right? A wall is going to have some measure to it. And so this became our proper solution, which gave us not a number. It gave us something we could substitute into that original equation, which allowed us to find the height of the wall, which then allowed us to find the width of the wall. So pretty fun. Okay, so there's a couple of examples of what you're doing for the problems on pages 137 and 138. Your assignment is numbers 1 through 13.